Okay, this video and the next one are fairly short, primarily because all the techniques that you saw in the first two sections of this chapter, solving equations, can be applied to solving inequalities, with only one or two little extra considerations. So the biggest one has to do with multiplying or dividing by a negative, and we'll save that for part two. So part one's going to be pretty short. Let's take a look at an example of solving a straightforward inequality. X minus 4 greater than or equal to 10. So we can just add 4 to both sides of this. If we add 4 to the left, we get x. If we add 4 to the right, we get 14. And the direction of the inequality stays the same if we're just adding or subtracting. And that applies to adding or subtracting a constant or adding or subtracting a variable. Let's draw the solution to this. So we'll put 14 in the middle there, put a couple of tick marks on either side of it, 12, 13, 14, 15, 16. It is a solid circle because it's greater than or equal to, and we want to go to the right. Now, to check, and this is the big thing that you want to make sure you get right with inequalities, you want to make sure you get the graph pointing in the right direction. You need to check a couple of values, and I would suggest checking both one value that should make it a true statement and one value that should make it a false statement. So, for instance, if I check 15, that is indicated on my graph as being part of the solution, so it should yield to a true statement. Now, you want to go back to the original statement to check, because that'll also catch mistakes that you've made. If you plug in 15 to x minus 4, you get 15 minus 4, which is 11. Ask yourself, is 11 greater than or equal to 10? And the answer is yes. Now, this isn't going to catch a mistake that you made in solving the inequality. It'll just catch the directional mistake. So if you want to check 14, you should get an equation or an equality here. So if you plug in 14, 14 minus 4 is 10, and that is the same as the right-hand side. Now, in this case, it's part of the solution because 10 is equal to 10, so therefore 10 is greater than or equal to 10. But the only value of plugging in 14, which is kind of like our boundary point, is to check to see whether we made any mistakes in the solution, not to check whether we got the direction right. As I said, it's worth checking something that should yield a false result, and the easiest one in this case is to plug in 0. If you plug in 0, you get 0 minus 4 on the left, which is negative 4. That's clearly not greater than or equal to 10, which is what we hoped for or expected. Let's take a look at another one. 8 less than 2 plus x. So the easiest thing to do here is to subtract 2 from both sides. If I subtract 2 from the left, I get 6. If I subtract 2 from the right, I have the x on its own. Now, 6 is less than x is our solution, but with inequalities, much more than equations, I would suggest that you want to rewrite this so that the variable is on the left-hand side. It is just a much more standard way to do it, and it's going to lead to far less confusion. So you have to be very careful. If you put the statement there in the reverse order, you have to make sure that you change the direction of the inequality. So saying that 6 is less than x is the same as saying that x is greater than 6. So it is exactly like relative statements we make in English. To say that I am taller than my brother is the same as saying my brother is shorter than me. So when you change the direction, you have to change the statement from a less than to a greater than in this case. Let's do the graph. And we have 6 somewhere in the middle there. We can do 4 and 5, 7 and 8 on either side. It's a hollow circle. We want to indicate the numbers to the right here because it's x greater than 6. If you plug in 6, you should get an equation or a left-hand side equal to the right-hand side. 8 is less than 2 plus 6, so 8 is less than 8. Well, we're not worried so much about the less than here, but the 8 on either side tells us that we got the boundary right. And let's plug in 7. If we have 8 less than 2 plus 7, that's 8 less than 9. That's true, so that is part of our solution. If we plug in something to the left of 6, and again, the easiest one here is 0, we should get a false statement. 8 is less than 2 plus 0. 8 is less than 2 is false. All right, let's try one more here. What if we have 3x minus 4 less than 2x minus 6? So what's the easiest thing to do here? Well, we want to collect the x's just like we do when we're solving equations. So if we subtract 2x from both sides, we'll be left with an x on its own on the left. And now it makes sense to add 4 to both sides to get x on its own. And if we add 4, we end up with x is less than -2. So let's do the graph for this. We'll put the -2 in the middle of our graph, and a couple of ticks either side, -4, -3, -2, -1, and 0, for instance. It is a strict inequality, so a hollow circle, and we're indicating all the values to the left of -2. Let's try plugging in -2 to make sure that we get the left-hand side and the right-hand side the same. If we plug in -2, we get on the left 3 times -2, which is -6 minus 4, or -10. If we plug in -2 on the right, we get 2 times -2, which is -4 minus 6, which is -10. So at least we know we didn't make any mistakes in the solution of this. It's a hollow circle, though, because -10 is not less than -10. And then let's try plugging in something like -3. -9 minus 4 on the left is -13. -6 minus 6 is -12 on the right. So -13 is less than -6. Let's once again try plugging in 0. That should lead to a false statement because it's not part of our solution. 0 minus 4 is just -4, and 0 minus 6 is -6. Well, -4 is not less than -6. So we know that everything looks good with this.